Welcome everyone. I am M.R.C.SAMPATHKUMAR, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology, Palkulam, Kanyakumari. In this video, we are going to discuss about the subject ME8595 Thermal Engineering 2. In this, we are going to discuss about the unit 1 steam nozzle problems. Before going into the problem, we are going to see what is steam nozzle. First, introduction on steam nozzle. A nozzle is a duct of smoothly varying cross-sectional area in which steadily flowing fluid can be accelerated to a high velocity by a drop in pressure of the fluid along the duct. A steam nozzle may be defined as the passage of varying cross-section through which the heat energy of steam is converted into kinetic energy. The steam nozzle major function is to produce the steam jet with high velocity to drive the steam turbines. The diagram shows the nozzle where the cross-sectional area of nozzle is decreasing from entrance to exit. Therefore, the velocity of the fluid is increasing and therefore the pressure and temperature drop occurs. Now we are going to discuss about the problem number 1. First, the problem number 1. Determine the throat area, exit area, velocity for the steam nozzle to pass the mass flow rate of 0.2 meters per second when the inlet conditions are 10 bar and 250 degrees Celsius and the final pressure is 2 bar. Assume the expansion is isentropic and the inlet velocity is negligible. Use PV power 1.3 which is constant. Don't calculate the HS chart. From the question we have to write on the given data. First, the mass flow rate of a steam through a nozzle MS which is 0.2 kg per second. Initial pressure P1 is equal to 10 bar which is 10 into 10 power 5 Newton per meter square. Then initial temperature 250 degrees Celsius. Then we are converting into degrees Celsius to Kelvin. So we are adding 273 and getting that 523 Kelvin. Final pressure P2 is equal to 3 bar which is 3 into 10 power 5 Newton per meter square. Then we know that PV power 1.3 which is equal to constant where N is equal to 1.3. From the question we have to find out the throat area A2, exit area A3 and exit velocity C3. From the steam table, for P1 is equal to pressure 10 bar and a temperature T1 is equal to 250 degrees Celsius. We are getting the specific volume which is 0.233 meter cube per kg. And we know that formula P2 by P1 is equal to 2 divided by n1 plus 1 the whole square n divided by n minus 1. So substituting the values we are getting that P2 by P1 is equal to 0.5457. So we are substituting earlier and getting that P2 is equal to 0.5457 into P1 which is equal to 0.5457 into 10. We are getting P2 is equal to 5.457 bar. At throat we are getting the velocity C2 is equal to, we know the formula, root of 2n divided by n minus 1 into P1 V1 in the whole bracket 1 minus P2 by P1 the whole square n1 minus n. Then we are substituting all the values. C2 is equal to, then we are getting the C2 is equal to 513.5 meter per second. Then we know the specific formula that is small v2 is equal to small v1 into p1 divided by p2 the whole power 1 by n. Then substituting the values we are getting that small v2 that is specific volume v2 is equal to 0.713 meter cube per kg. Then we know the formula mass flow rate ms is equal to a2 into c2 divided by v2. We know all the values except a2. From that we can calculate the value of a2. We are getting a2 is equal to 0.2 into 0.3712 divided by 513.15. So we are getting a2 is equal to 1.446 into 10 power minus 4 meter square. At exit, same the velocity formula is used. C3 is equal to 2n divided by square root of 2n divided by n minus 1 p1 v1 and a1 into 1 minus P3 divided by P1 whole square n1 minus n. We are knowing all the values. We are substituting and getting that C3 is equal to 991.45 meters per second. Also we know the formula for specific volume. Summa V3 is equal to B1 into P1 divided by P3 the whole square 1 power n whole power 1 by n. We are substituting the values. We are getting V3 is equal to 0.8035 meter cube per kg. We know the formula mass flow rate ms is equal to A3C3 divided by small v3. We are getting the value A3 is equal to 0.2 into 0.8035 divided by 791.45 divided by getting that A3 is equal to 0.23 into 10 power minus 4 meter square. Then result, we have to write out the result, that is throat area A2 is equal to 1.4446 into 10 power minus 4 meter square, and exit area A3 is equal to 0.23 into 10 power minus 4 meter square, and exit velocity 3 is equal to 791.45 meter per second. Thank you.